In this video, we're going to talk how to simplify radicals containing variables. These are like those from 15.1, numbers 51, 55, 57, 59, 61. This is going to be a big topic. 63, 65, and 67. Now, the book gives instructions to say that we need to assume that all the variables are positive. We're not going to be doing that later in pre-calculus. So I'm going to show you a rule right now that you can hang on to. It's an important rule, and it's something that your teacher may tell you in class. So I will work the problems this way, and then we'll figure out what to do when these numbers are positive numbers. So by definition, when I take the square root of something that's squared like this, I get the absolute value of x, but it's a little bit bigger definition than that. Whenever there's an even exponent on the inside of an even root, and it comes outside and has an odd exponent on it, I need absolute value bars around it. So another example of this would be if I had the fourth root of x to the 12th, and 12 divided by 4 is going to be 3, then I would need to have absolute value bars around either the x and then cube that, or around the entire x cubed. Why? Because if I had a negative number raised to an even power, it would automatically be positive, and then the fourth root of that positive number would have to be positive. But if this negative number were raised to an odd power on the outside, it would be negative, and that would be the wrong answer. So the book is trying to make it easy for you by making all the numbers positive, so you don't have to think about absolute value bars. That's okay for right now. I just want to show it to you. It is something that we have to think about later in pre-calculus and calculus. All right, we won't think about that anymore for this video though, so I'm going to get rid of that. Our first problem is the square root of w squared. Because we were told that w has to be a positive number, this is just going to be w. I'm going to take half of 2 is 1. Why half of 2? Because these indices here, there's an invisible 2 right there. This is going to be the denominator of this fraction, and that simplifies to this, and it's like that. The square root of 49x to the 8th is going to be the square root of 49 times the square root of x to the 8th. We know that the square root of 49 is 7. Half of 8 is 4. Square root of 100x squared is going to be the square root of 100 times the square root of x squared is going to be 10x. The square root of a to the 12th, b to the 2nd. It's going to be the square root of a to the 12th times the square root of b to the 2nd. 12 divided by 2 is 6. 2 divided by 2 is 1. Now have the square root of 81, a to the 12th, b to the 18th. It's going to be the square root of 81 times the square root of a to the 12th times the square root of b to the 18th. The square root of 81 is 9. 12 divided by 2 is 6. 18 divided by 2 is 9. Now we're going to deal with a cube root instead of a square root. The cube root of s to the 9th, t to the 24th. So our denominator is going to be 3 now. It's cube root of t to the 24th. So let's just write that with denominators as rational exponents, like that. 9 divided by 3 is 3. 24 divided by 3 is 8. This next one's a little interesting because it's got a negative on the inside. It's a cube root of a negative 64. X to the 18th, y to the 3rd. So remember that negative 1 squared is 1, and negative 1 cubed is going to be a negative 1. So I'm thinking about perfect cubes. This is going to be the cube root of negative 1 times the cube root of 64 times the cube root of x to the 18th times the cube root of y to the 3rd. So this is a negative 1 times the cube root of 64 is 4 times x to the 18 divided by 3 times y to the 3 divided by 3 is a negative 4, x to the 6th, y to the 1st. All right, I have one more problem here. And it is number 33. Okay. Y to the 6th over 4. I actually have two more problems here. So I have the one I told you that was like number 67 in the textbook. I also have one that's like number 69 in the textbook. So when I have a square root over a fraction and a fraction inside of a square root like that, I take the square root of the numerator and the square root of the denominator, or any root. It doesn't matter whether it's a square root or a cube root or fourth root or anything. So this is going to be the square root of y to the 6th over the square root of 4 is going to be y to the 6 over 2 over 2. It's going to be y to the 3rd over 2. And this next one is like number 69 from the textbook, the square root of 64 x to the 2nd over 25. The square root of 64 x squared over the square root of 25 is the square root of 64 times the square root of x squared over the square root of 25 is 8x over 5. All right, that's it for this video. It was a pretty major topic in this unit here. So remember, even root, even power on the inside, odd power on the outside. We really should use absolute value bars if the teacher doesn't tell us that all the variables represent positive values. Doesn't matter if the power on the inside was odd to start off with, doesn't matter if the index was odd, doesn't matter if the power was even when we come to the outside. All of those things take care of that issue with the negative sign. All right. We'll see you for the next video.